NASA loses contact with key Mars orbiter. Without warning, one of Mars's most important orbiters suddenly went quiet. NASA has lost contact with the MAVEN spacecraft, an explorer that has shaped our entire understanding of the Martian atmosphere and supported nearly every surface mission on the planet. In this video, we break down what happened, why the silence is so surprising, and what NASA is doing to bring MAVEN back. MAVEN's communication loss began during a routine orbital event. It passed behind Mars from Earth's line of sight, which is a normal occurrence that temporarily blocks radio contact. Usually once the spacecraft emerges from behind the planet, communication resumes instantly. This time, however, NASA's ground stations received nothing at all. What made this moment especially alarming is that MAVEN had just sent back telemetry showing completely normal system performance. Power levels, onboard computers, and orientation controls all appeared healthy before the blackout. So, as soon as the silence continued longer than anyone expected, NASA's engineering teams launched a full analysis of MAVEN's final data packets. They really examined everything, searching for even the slightest anomalies, like changes in spacecraft orientation, power irregularities, or any unusual patterns in attitude control behavior. One possibility, is that MAVEN automatically entered safe mode. That's a protective state where it shuts down non-essential systems and reorients itself to maintain power and thermal balance. In this state, communication can weaken or even stop if the antennas aren't aiming toward Earth anymore. Right now, engineers are simulating MAVEN's orbital position and orientation to estimate where its antennas might be pointing after the anomaly. The Deep Space Network antennas are still sweeping multiple frequencies, just trying to detect even a faint signal that could help us determine the spacecraft's status. MAVEN's disappearance is significant because of the mission's central role in understanding Mars's atmospheric evolution. Its instruments measure charged particles, magnetic interactions, and atmospheric gases, allowing scientists to quantify how Mars loses atmospheric material into space. Through long-term observations, MAVEN revealed that the planet loses around 100 grams of atmosphere every second, with escape rates rising during periods of stronger solar activity. These findings helped clarify how Mars shifted from a warmer, wetter environment to the cold, thin atmosphere world we see today. Beyond this primary mission, MAVEN observed dynamic atmospheric events including diffuse auroras and interactions between solar particles and Mars' crustal magnetic fields. It also collected unique data during the passage of the interstellar comet 3I/Atlas near Mars, documenting rare atmospheric responses. Operationally, MAVEN became a vital link for Mars exploration. Since rovers cannot send large amounts of data directly to Earth, MAVEN acted as a high-efficiency relay, forwarding information from Curiosity, Perseverance, and other surface missions. This relay system improved data rates, allowed smoother operations, and served as an essential communication bridge. Although other orbiters remain active, MAVEN's specific combination of instruments, orbital position, and relay capability is unmatched. Its atmospheric sensors probe regions that other spacecraft cannot, and its relay role has become central to daily Mars operations. Once MAVEN failed to re-establish contact, NASA initiated its standard recovery protocol for deep space spacecraft. The first priority was an extensive signal search using multiple Deep Space Network antennas. These antennas scanned wide frequency ranges and multiple signal strengths to detect any trace of MAVEN's transmitter. Even a brief, weak signal would help determine whether the spacecraft remains powered and stable. Engineering teams then began assessing whether MAVEN triggered safe mode, which is basically a condition where only essential systems stay active. In safe mode, the spacecraft typically points its solar panels toward the sun, and that might turn its antennas away from Earth, causing, a communication loss. Figuring out whether this happened is really important for deciding which commands to send next. At the same time, NASA is analyzing simulated spacecraft behavior under different scenarios to predict MAVEN's orientation and its likely antenna direction. These simulations, they help refine the angles and frequencies the deep space network should use for reacquisition attempts. While recovery efforts continue, NASA has temporarily shifted communication responsibilities to other Mars orbiters to make sure the rovers remain supported. Mars Reconnaissance Orbiter and Mars Odyssey can handle parts of MAVEN's workload, but, their capabilities just can't fully replace its atmospheric tools or relay geometry. This unexpected silence has also, renewed discussions about modernizing Mars' communication infrastructure. As more missions head toward the planet, a robust and updated relay network is becoming increasingly important. MAVEN's unexpected silence is more than just a technical issue. It's a moment that really highlights how fragile and extraordinary our presence on Mars truly is. For more than 10 years, MAVEN has helped decode the planet's past and kept missions on its surface connected to Earth. Now, its sudden quiet leaves a gap that's felt across science, exploration, and communication. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries, and don't forget to leave a comment below. Thank you for watching, and see you next time.